All right, this week we're going to go down to the tropics. Uh, Anywhere between 23.5 degrees north, 23.5 degrees south is considered the tropics. Basically, the area the sun crosses vertically at some point during the year. This area really does not get much in the way of, it gets no frontal passages. The weather's pretty uniform. So because of that, it's kind of a unique area, what forms there. So we're going to talk about tropical cyclones and tropical weather somewhat this week. So with that, there are a type of thunderstorms, obviously, that occur in the tropics because we got a lot of heat, a lot of moisture. There's a lot of thunderstorms down there. And these can be like literally in tropical squall lines. They look literally like mid-latitude squall lines, except they may not have the hail type of severe weather or maybe no tornadoes, but they can get some pretty strong wind gusts and very intense rainy areas. One of the interesting things that's done on a meteorology map with these is we do what we call streamlines. A streamline is basically you look at the wind and just draw a line literally along the wind barbs. And all it does, it actually shows you areas of convergence and divergence along where they are at the surface. And since the surface is the main feature that we're interested in the tropics, streamlines do a lot for us there. They're great for identifying easterly waves, for example, which is a form of tropical weather. Hurricanes originate over the tropics as well. They always form over most of the tropical water. The water's got to be pretty warm for a hurricane. And it is very different than an extratropical cyclone. The other week, you all were asked in your critical thinking to talk about the differences between a warm core system and a cold core system. Several of you told me that warm core systems were stationary. Well, most of them are. I agree with you. However, some are not. A hurricane is an example of a warm core system. So a hurricane starts by being very hot, literally, in the center of the system. There's warm tropical moisture there, and it begins with that. And because of that, the most intense part of a hurricane is right near the surface. It actually weakens with height, and you get an anticyclone on top of a hurricane. The stronger the hurricane, the more intense the ridge or the anticyclone might be over top the hurricane. If you actually watch the clouds spiraling around a hurricane, you'll see an anticyclone in the very highest level clouds. The eye of the hurricane can be anywhere from 6 to 4 miles across. You can see here very intense convection around the eye, literally almost no clouds in the center of it. And if you're in a Hurricane Hunter aircraft, they say some of the eyes are like a stadium where you have tremendous vertical cloud growth around the eye. Big thunderstorms. And right in the middle, nothing but clear skies. So looking at a hurricane, you have winds that spiral in on what literally are spiral bands on the outside of the hurricane. The areas of convergence that develop thunderstorms. Thunderstorms aren't maybe as high or as intense as you get closer to the center, but they're areas of showers. The further away, they're more showery. The closer in they get, maybe they'll have some lightning with them. Maybe they won't, but they'll get more intense rainfall. And actually, as you go in towards the eye, you can see all this tremendous air rising up in the eye, right around the outside of it. Well, the air's got to sink somewhere, so what it does, it sinks down the eye. And think about it, air sinking is warming. So the actual warmest temperatures in a hurricane are right in the eye. They get quite warm. So what are some of the necessary conditions? Need a high sea surface temperature. It's got to be greater than 80 degrees. And the ocean's got to be that warm to at least 150 feet down. Think about that. That's pretty good depth. Another thing about a hurricane is it needs some Coriolis effect. In other words, you don't get hurricanes forming right along the equator. They've got to be somewhat inland, somewhat north or south of the equator. And you don't want winds shearing these thunderstorms apart like we do up here in our latitude. We want very weak wind shear. And the air should be pretty humid throughout the whole mid-troposphere. So that means a lot of moisture. Here is an example of where some warm water is located. You can see on the left, basically the Gulf Stream. You can see these pools of warm water that are just offshore. And then down in the tropics, down in the Gulf of Mexico, there's like the warm core eddy in the western Gulf that sometimes it can get temperatures into the 90s, warm water temperatures there in the summer. And then the loop current that literally forms down in the Caribbean Ocean comes up into the Gulf and then eventually heads out as part of the Gulf Stream. All that area is very, very warm, typically temperatures well above 80 degrees starting by May, literally, and continuing into October, November timeframe. One of the other things that's interesting with the Coriolis effect needed, there are some islands down pretty far south. I made a trip down to Aruba once and on a cruise, and Aruba doesn't get hurricanes, almost never. Why is that? Because it's within literally very close to 5 degrees of the equator. So if you wanted to live on a very tropical island and not have to worry about a hurricane, go find an island that's very close to the equator. The other thing is you need the cumulonimbus clouds to organize. So wind shear would tear them apart. And guess what? During El Nino years, there is an unusually strong winds aloft over the Atlantic. So Atlantic hurricanes typically are less frequent during that time. On average, this is a phenomenal number. You think about it, almost 85 tropical cyclones globally on average, and half of those strengthen into a hurricane or a typhoon. And guess what? While we always think of the Atlantic as being active, the most active area in the world is the Western Pacific Ocean. It has, on average, the most tropical systems. So if you wanted to see them, that's where you go. And here's the map. And you can see all the tropical systems out here affecting this area and the typhoons. Typhoons are just another name for hurricanes or hurricanes here. And you get them in the Indian Ocean as well. You'll notice, you would think, oh, you might get them down here off of Brazil or somewhere in that area, being close to the equator. However, you don't, because of warm, cold air. Cold water literally comes around in this area. Remember when we learned about our big old high pressures that tend to sit around 30 degrees? Well, remember they're moving the opposite direction down that area, so they tend to have cold water on the South American coast. Here's the frequencies. You can see here, most tropical systems occur in September. Late August, September is really the peak, and gradually still going down in October. However, you can almost find them in every month except maybe February or January. But there have been one or two actually outliers during those months in the Caribbean. And here's where they begin to form. The first place that warms up on the water is literally, think about it, the water's in a small area. It's not as deep relative to the big Atlantic out here. So the first areas that begin to warm are the Gulf of Mexico, Caribbean Sea, and they become your areas, your hotspots. Then as the ocean begins to warm up, that begins to become the area between more and more potential for hurricane activity to develop. And gradually, as the oceans cool, it shifts back towards the Gulf Stream and towards the Gulf of Mexico, Caribbean Sea. And there are things that come off of the east coast of Africa, little tropical easterly waves. And they're what triggers a lot of these. Easterly waves, interestingly, lowest pressure kind of develops to the south towards the equator and then has like a trough of low pressure moving northward along that. And most of the precipitation falls on the east side of an easterly wave, not on the west. West would be over here, east side of it. So you get the most convergence and most precipitation. But as these waves come off of Africa, they begin to develop thunderstorms, and that's where you begin to get your chances for convection to develop and become more organized and develop into these tropical cyclones. So easterly waves are many times a good trigger for this kind of severe hurricanes. Another thing that happens, however, is you get something called the Saharan air layer. This is a lot of mass of dusty, dry air. We talked about hababs the other week coming out off of in the desert southwest. They also occur over the Sahara. And when they do, you get these dry thunderstorms that develop, push a lot of this dusty air aloft, and that dusty air comes then westward over the Atlantic, and it's very dry. That's part of what inhibits it. It typically is very stable, another factor that messes everything up as far as hurricanes go, and it probably has a lot of wind shear with it. Oh yeah, none of those things are good for hurricanes. So when these areas, the Saharan air layer goes across, they can be tracked on satellite, and if they come into areas where a hurricane may be beginning to develop or a tropical storm, you can almost watch the convection die out. So they kind of track these all year long. But when there is favorable condition, water vapor condenses within the storm for latent heat release, so you have more heating. The heated air rises because we know hot air rises fast. And you begin the expansion of cooling of that rising air, more condensation, more latent heat. Because you got tremendous amounts of water available to these systems. And this triggers that sharp drop, and you wind up getting the different stages of a hurricane. Begins with a tropical depression. Basically, winds reach 23 miles per hour or higher, but less than 39 miles per hour. Tropical storms, where they are assigned a name, these 39 mile per hour sustained winds, and hurricane 74. And as the storm weakens, then the system is downgraded the same way. There are certain damages that occur with hurricanes, however. We're going to talk a little bit about these. I wanted to look at two real quick. Storm surge causes more deaths and damage than anything in the U.S. And rain, heavy rain and flooding. Notice tornadoes, winds are much less. So the most significant damages, the most significant danger to the person is from flooding or storm surge, which is really flooding. Here you can see, for example, severe flooding in Port Arthur, Texas. There was tremendous rain, for example, from Harvey. Flooded Houston area tremendously. Gave them well over 50 inches of rain in some spots in here. Think about that. 50 inches of rain over several days. That's going to flood anybody. And you can see some more in this area as well from Amelia. What causes the wind? Well, wind is caused by pressure gradient force. We've already learned that part. And the speed of the air actually squares the force put on a building. So every 10 meters, you have 100 times more force, 10 knots, basically. So think about it. You're talking 70, then you go to 100. There is a significant increase in the amount of force put on your building with that kind of wind. Winds diminish rapidly at landfall. It lost its heating. Hurricanes are based on all that moisture and the heat coming up from that latent heat released. And because that can't occur over land, it loses that, so the winds are going to be diminished. Friction is going to slow the winds down, especially at the surface. So what happens, another part of that is winds will gradually slow down. The storm is going to weaken as it comes inland. However, if the storm's moving very fast when it comes inland, those winds might last a little longer. That's why sometimes, even in Ohio, if you have a very fast moving storm, it might cause some strong and damaging winds to reach your area. I wanted to show you an image here of storm surge. When you have storm surge, and you're going to be talking about it in Sandy, because it's one of the biggest impacts from Sandy is storm surge. What happens is, think about if you have an east wind blowing into the shore. It's pulling the water from out in the ocean with it. The water is going to be moving with that direction. Gradually, that water is going to get higher and higher if you have stronger and stronger winds. So literally, what happens is you raise sea level. A storm surge literally can raise sea level by, here it shows it as 5 meters, or 15 feet, 15, 16 feet. Maybe even get over storm tides of that much. Think about it. If that water level is 15 feet higher than where it normally would be on a high tide, that's a lot of area inland that's going to get covered with a storm surge. And then you put on the waves on top of that. It's no wonder that houses are destroyed along the coast. You can actually see it very clearly. Here is an area that was not affected before Michael, and here it is after Michael. And all this damage is due to storm surge. You can see the total devastation here of these houses from storm surge. Here are some classic storm surge. Camille, 24-foot storm surge. Hurricane Katrina had storm surge that flooded New Orleans. Sandy, and you're going to see this, at 12.7 feet, it had an extremely large area of very strong winds that blew directly into that area. And that pushed the water up, and it occurred at a high tide, another point that really caused devastation up there. And we have a prediction model called SLOSH, Sea, Lake, and Overland Surge from Hurricanes. That does a pretty good job of giving us an estimate when we have the winds pretty close to how much storm surge are going to be. We look at trends in hurricane frequency, and the last several years we've definitely had a lot more hurricanes. On average, between 1995 and 2019, we had 14.9 hurricane tropical cyclones. Look at back in the 1970s, 9, roughly around 9, 5, almost 6 less than we're getting right now. And I can remember when I was in college and I wanted to go see a hurricane. I thought I was, probably looking back, maybe I was an idiot, but I was going to Florida State. I thought, oh, for sure, the 4 years I was there, there'll be a hurricane somewhere around me. The 4 years I was there, we never had a single hurricane come into anywhere within 300 to 400 miles of where I lived in Florida. So very rare at that time. Now, wow, almost all the time there's a big hurricane coming in. One of the interesting things, too, is the Atlantic Ocean has warm and cold cycles. And during that time, it was in a cold cycle, very cold cycle relative to normal. Now it's in a warm cycle, and it's actually had some of the hottest temperatures on record. Another impact is El Nino. If El Nino is occurring, like I say, it's going to give you stronger winds. So all these are being looked at to try to see what's going to happen with hurricanes in the future. If global warming, for example, was 2 degrees warmer world, what will happen? Well, one of the things they're finding is there'll be more storm surge. Well, remember, water heats up, it expands. Tropical rainfall rates will be higher because the air temperature is warmer. The global intensity will increase. But interestingly, they didn't exactly find that there would be that much more number of hurricanes. What they found was they'd be more intense hurricanes. But it's still ongoing, and we're still learning. But really there's a huge threat now to southeastern United States, the Gulf of Mexico area, and all from hurricanes. Because there was a law back in the 1970s and 80s when everybody thought it was okay to go to the coast. Now they're discovering, hey, there's a little problem here. Barrier Islands. I actually have a barrier island near me called Willoughby Split. That barrier island was formed in hurricanes in the 1800s. Guess what? There's over 1,000 homes built on that island. an island that was formed by hurricanes. So at some point, there are going to be hurricanes again that take that island away. All those homes will probably disappear. But barrier islands can protect you. They take the brunt of the storm. All the worst storm surge hits there, the worst waves hits there, so that the area behind the barrier island don't get quite as much. Obviously, there are evacuation routes, all that are out there. People need to get out of hurricanes. This thing I'm giving you this week in your discussion to talk about is a scenario that happens all too often in people trying to make decisions whether to leave or not leave their home when it's in the path of a hurricane. And I want you to think about that this week. Maybe you'll never live at the coast, but maybe you will. So it's something that everybody will face at some point that lives at the coast. And they're doing a lot of strategies now to minimize the loss of life. And they're actually looking at long-range forecasts to hopefully have a better idea of what it will be over the summertime, how many there'll be. And Project Fury was an old case where they tried to actually put silver iodide particle crystals into hurricanes to reduce them, and discovered that, oh yeah, it doesn't work when the water is warm, because hurricanes are a warm system, so there's not a lot of cold ice crystals in a hurricane to start with. So I just wanted one last thing to show you here. This was last year, and you can see on this map all these hurricanes and everything going around here. And with that, here literally is all the various models that are used to track these hurricanes. So just something to look at. Hope you got a little bit out of this, and let me know if you have any questions.